Hiren Kumar is a senior data engineering architect with over 18 years of experience modernizing enterprise data platforms for global Fortune 500 organizations, delivering up to 40% system performance improvement and 20 to 35% infrastructure cost reduction through large-scale migration from legacy ETL platforms to cloud-native lakehouse architectures. He specializes in Databricks based data engineering, so we're really excited to hear about that tonight. Unity Catalog-driven governance and building scalable, secure, and real-time analytics platforms. He's led multiple enterprise-wide transformations from tools such as Informatica and traditional data warehouses to Databricks, establishing governed data foundations using Unity Catalog and enabling advanced analytics and AI use cases on top of trusted data platforms. His leadership focuses on architecting durable data platforms, enabling teams to move faster with confidence and translating data and AI investments into measurable business outcomes. So thank you so much for volunteering tonight. We're very excited. I'm going to turn it over to you and we'll go from there.
Yeah, thank you, Katie. Good evening, everyone. So I think, like Katie has already introduced, my name is Hiren Kumar Dolaria. Having total like 18 years of experience, mainly in the data engineering side. It's great to see so many leaders and experts today in this room. Mainly today we're going to cover some traditional ETL part. So here, I used to work on Informatica Power Center. So we're going to quote that example here, but it's not like that only one tool which we are referring here, but it's like basically, yeah. So the transition from traditional ETL to govern AI on Databricks. So again, there could be like a multiple latest and advanced tool in market. But since I am working on Databricks, we're going to mainly talk about like Databricks, and then the feature which is on top of Databricks is like a Unity Catalog. And then we'll see some of the business use cases which we have built explicitly on Databricks and Unity Catalog to have like, service agent on top of it. And then we'll also see like, some of the examples where this combination of Databricks, Unity Catalog, and AI virtual assistant, how it is helping to the healthcare and life science industry. Agenda for today. Yeah, we have roughly 18-19 slides. I would say the step one, we're going to see some of the foundation before. Basically, for any application, the foundation is like a data. And to have the data, we need to have like, ETL pipeline, right? So first thing, we're going to understand why traditional ETL tools fail to support modern need. Second thing, if traditional ETL fails to support the modern need, what do we have? So as an option, as I said before, like Databricks is just one of an option. So we're going to talk about Databricks, which is like unified data platform. And then we will also talk about Unity Catalog, which is supported by Databricks, which is kind of, governance at scale. In point number two, the step two, we're going to talk about the application which is like AI virtual assistant, the service agent, which is built on top of the Databricks and Unity Catalog. So whatever we discuss today, though it might be like AI security, but it will be mainly keeping Databricks in the center. So all of these features are supported by Databricks, and that's what we are going to cover. We will see the architecture and the business values, and also discuss some of the results and the roadmap forward, right? And then we would be having like a question answer session. Depends on the time what we have left. Next. So the challenges with the modern data reality, right? I mean, so it's like, the pretty non-challenges all of us know. So whenever we talk about any kind of system development, or maybe like any kind of ETL pipeline development, right? So we always think of 3 V's first, right? Which means the variety of data. As we know, I mean, if we talk about 10, 15 years back versus today, right? The variety of data is like, altogether different. Now we are dealing with images, videos, and whatnot, basically. Earlier, it used to be like, mostly a plain text, right? And it makes we are storing JSON and all those things. But today, like, the data is completely unstructured. So that is the one of the bottleneck with our traditional ETL, because it does not support all variety of data. Let's say if I talk about videos, if I would like to process videos or images through the Informatica Power Center, for an example, it is not, I mean, not that easy, I would say, right? So that is my limitation. And then, I mean, in the last field, if you see the current requirement, right, it says like 80 to 90% data in today's market is unstructured. The second thing is velocity. So look at this. I mean, if we just think about ourselves, right? I mean, how many emails we have sent today, or maybe how many emails we have received today. The one thing, how many images we might have exchanged through the WhatsApp, Facebook, or any other platform, right? Or maybe Katie, like she had sent couple of messages today about today's conference, right? So we have like a huge data. So it's kind of a velocity, right? The amount of data which is like a flowing to our systems is like a too huge. Earlier, it used to be like, batch job. So like my Informatica Power Center, the workflow, I just need to schedule it once. I would say, okay, run it at 9 p.m. Eastern time every night so that, the throughout the day, whatever data I might have captured, the data will come in my database. And next day, it will start reflecting in my dashboard. But now that is not the case, right? We need to have almost near real time or real time data. That is our requirement. The third one is a volume. So I think, I already covered a bit of it. When we talk about the velocity, if the velocity is high, definitely volume is going to be high. And now we are talking about like, the basically PB and ZB, right? Earlier it was like, I mean, 10 years back, if I remember, during the interview, many of the interviewers used to ask, okay, what is your table size? And we used to say it is in GB or TB at max. 10, 15 years back, right? And these are the big tables. But now, the size has been increased by multiple, basically. So these three V's are the main challenge, and I would say are the limitations of this traditional ETL, because either they partially support or some of the fields, some of the attributes, they do not support at all, right, with the traditional ETL. And if we have like, these challenges, variety, velocity, and volume, definitely the cost will be the significant. If we still go with our traditional ETL just to cope up with my velocity and volume, let's say if we talk about the velocity, earlier it was like kind of a batch job, right? And if I feel that I would like to make it almost near real time, it means that I need to keep running that Informatica job again and again, again and again. Still, it will not be a real time job, but still, like, if to meet that kind of requirement, we need to run it frequently. And if we run it frequently, definitely we need more resources, and that's going to add up the cost part. Last one is a trust, which is not going to come even though, like we pour a lot of US dollar, right? Because, trust is the main thing. In the Informatica, we did not have any kind of lineage. I cannot go back and track that, okay, which record is inserted by whom, what sort of access are having with this developer or this team, right? Versus like what do we need today? We need a full audit trail. If we talk about the AWS, right, we have those kind of features right now, right? So this is just like, one AWS, but let's say if we are using Databricks as ETL tool, how can we get that? So we're gonna understand that too. So the last one, like I got it from the Gartner predicts, right? It says that the 80% of the enterprise will use GenAI by 2026. I'm pretty sure like most of us, or maybe all of us, have started using AI somewhere, somehow in some of our projects, right? So most of us are going to start using this by year end, but the main challenge is we're gonna struggle with like return of investment because of the data integration gap. So I think, the data is an oil, right? It's like a new oil, we can say. If we do not have the proper and up to date data, it's going to really hurt us back. So that's what the problem we have through the our traditional ETL. Traditional ETL does not support it. Main thing with traditional ETL, if we use it, right, the ETL is like a one part. And then on top of that, we used to have like, kind of a BI analytical tool. And then if we talk about the AI solution on top of it, it's almost like, very hard, or it's like, time consuming and the cost taking part, right? Because, like most of my data are like kind of silos. My ETL job, one is fetching data from SAP, another is fetching from the Salesforce, and so on and so forth, right? So that is really a challenging part with our traditional ETL tools. If I go to the next one, and if we talk about the Databricks, whatever problem just now we discussed, all of those problems are addressed by the Databricks. Again, as I said before, I'm just repeating. So Databricks could be one of the tools. There could be even better or maybe similar tools in the market, but we will just, keep focus on the Databricks here. This is like just one platform for the data engineering, analytics, and AI. It supports all of this three aspect of us, right? Basically, so we would like to have like a good ETL pipeline. Then we would like to have something which can support our analytics. And on top of it, in the recent time, we would definitely like to build something as an AI application or maybe a service agent on top of it, right? So all of these things are getting supported by the Databricks. The first thing first, unified workflow, right? So ETL and the streaming, it's on the same data basically. So I don't need to define a different job for different task. Within the same job, I can just, use it as like, to stream my data. And at the same time, even I can run this as a batch job. Second thing, this is like, 10 to 40%, 40x faster, right? Overall process is very quick. So this is, I mean, these numbers are from my own project, right? So I mean, our Informatica job used to run on the same data, some of our traditional data, and now we are running through the Databricks, right? We could see that, like, our jobs are running too fast, basically, as compared to our previous traditional systems, right? And then if my jobs are running fast, it means it's going to use the less resources, right? So we can say, like, we are roughly saving, especially I'm saying the ETL pipeline cost, right? So, like, more than 50% of the cost reduction by using the Databricks. And the last point is like open formats. What does it mean? So when we talk about the Informatica, right, we know that, it would support like my text data. And then when I have like a tool like Informatica or any other tool, right, what is to happen? I need to have some endpoint as a database. So I may use like Oracle, SQL Server, DB2, or whatever database our traditional ETL supports, right? But here it's like open format. What does that mean? It means that it is going to have like a Delta leg format through the Apache Park, right? So it means that, like, I don't need to worry about the formatting. It can give me like a Parquet file and then Delta file. So I can access them without having any kind of vendor dependency. Through the traditional ETL, if I load my data into Oracle, tomorrow if Oracle license cost is getting increased, right, it means that, like, I'm going to, I need to bear that cost. But here is like an open format. So, like, I'll be having like a Parquet format or a Spark format. So that is like, one of the advantage here. So mainly the four thing, one thing is storage. So as I said, it's going to cover the Delta Lake part. So our data are getting stored in Delta Lake. So here we are using AWS Cloud. So it would sit in my S3 bucket. Second thing is like a cloud object storage. So it's the same thing. And the last part is like open format. So I'm getting like a Delta or Parquet format. Governance, right? So we're going to talk in the next slide about the governance, but yeah, let me just, brief you. So Databricks is offering Unity Catalog, which is known as UC, right? It has all the security, access, data lineage, and the discovery part under the governance part. Third one is like a processing. Processing is real fast as compared to our traditional ETLs, because it is the cluster configuration, right? So if any of us are aware of about the Databricks jobs in the workflows, what do we have? Like, we need to attach a cluster to run any kind of pipeline, right? So this cluster depends on my data size. I can define the cluster size. And again, it's kind of a auto scaling. So the moment my job even feels that, okay, I have a larger volume of the data as compared to what I have been configured, it can, like, auto scale the configuration. So the configuration, the cluster configuration is like, the Photon engine, right? So as I said before, it can, like, basically I can provide a range of the basically workers and the drivers, right? I can say, okay, 2 to 8. So in minimum case, it will run with my 2 workers. And in the max case, it can go up till like 8 workers. So this way is kind of, like a auto scaling part. So I don't need to worry about my costing. It can take care of automatically. And the last part is like a auto optimization. So it's like a same story. If I have like a larger volume of data, I can increase my workers and the driver to run my job within my SLA. And the last part is consumption, where we will talk about, like, AI, ML, and then the BI and AI agents, right? So that will be something I'll cover as part of my use case. So this is what something like, our Databricks is offering versus our traditional database. So in the next slide, we'll just talk about the Unity Catalog, especially the governance part. Yep. So this is like a centralized control and distributed innovation. This is offered by Databricks. There would be, like, even more features in market through the Unity Catalog, but this is something like, these are the features which are widely used. If you see the latest innovation in the middle, right, this is something they have recently introduced. So to be very honest, even we are yet to try POCs on those features. But if we focus on the core functions on your left, on your right side, uh, sorry, right here, right, on your left. So the unified meta store, right, it gives like a cross cloud, cross region governance, single source of truth. So the Unity Catalog, it does not depend, like, whether I'm using AWS or Microsoft Cloud, Azure, or maybe a Google Cloud, right? It does not matter. So basically, like, it can support cross cloud, cross region governance, no matter where I'm storing my data, but, still Unity Catalog will support all the meta stores. The second thing is front-end security, right? So I can put, like, the security at the row level or even at the column level masking, right? So we know for example, let's say I have a traditional database, what I can do, I can put like a grant on my table, I can provide some kind of select access and update and all those things, right? Here in the Unity catalog, I can provide like, the very fine grained security. I can put those kind of access at my row filters or maybe a column masking, right? And automatic lineage. So the moment, let's say I have a table present in my Unity catalog. I'll show you the screenshot in the next slide, right? So let's say I have a table in Unity catalog. I'm preparing a materialized view on top of it. Or maybe I'm using in one of my ETL pipeline, right? So the moment I use it, like when you click on that object, it will say that, okay, these are the list of the dependencies we have on it, right? So it's just like, automatically track my data and, like all dependency tracking. The last part is data discovery, right? So this is mainly used for the AI application, vector search client, which we will see in the next slide. So latest innovation, it says like attribute-based access control, right? So I think almost the same part, but there would be some additional features which we are yet to explore on top of it. And the next one, the data classification is really interesting because, it seems like Databricks is claiming that, they can auto detect and then, they can do masking of the data, PII scanning, right? Based upon the data. Let's say if my data is having a social security or maybe a phone number or maybe some of other personal information, it can mask those details if they are not supposed to be shared. So we can set those kind of configuration within Unity Catalog. So basically, just to summarize this, the Unity catalog comes in like mainly three tiers, right? One is like catalog, second thing is schema, and third thing is like my tables or views or whatever it is basically, right? So when I talk about the catalog, it means that like, let's say if I have a project in my company, right? So that project can be a catalog. Within that, like I may be having like a multiple use cases. That can be my schema. And then within my schema, I could have a multiple tables. And the one important thing is like, these tables or schema, they can be used across, within the catalog. Or I can, like have like a soft link to use one of the object from one catalog to another catalog. Just to simplify this, I just, put like one of the screenshot, right, from the project. So for example, let's say currently we are working on a project called generative AI, right? So generative AI is my catalog basically, because like in a company, like we have a multiple projects and multiple initiatives are going on. So all of those initiatives are related to the generative AI. So we can say that, okay, my catalog is generative AI. Within generative AI, I could have like a multiple schema because like we have a different definitions. Let's say I'm dealing with service data because I would just capture like, okay, how many tickets have been raised by customers, how many instruments are bought by customers, okay, which instrument is with which customers, right? So those details comes under the services. So we can say services is like my schema. So Genia is my catalog, this is my schema, and within schema I can have multiple objects, right? And then again, if you see, for example, let's say some of the objects might be reusable to a different project or a different catalog, right? So if you see the last one, it's a D context. So context can be used by all projects, right? So I don't need to literally create that object. What I can do, I can create a soft link. If you see this glasses symbol here, right, it means that this is just like a soft link. This is not like actual table which we have created under this schema and this catalog. It could be with some different schema. So if you click on this, you will get all the history, right? So, and then some of these are like a tables. If you see the table symbol, these are the tables which have been created under this schema. Some of them are like views and materialized views, right, which we have created here. So now, for example, let's say I click on the CVA resolution time table, right? This is the object where I clicked on it. So in a moment, you will get the entire history. It says, okay, these are my downstream, these are my upstream. So whatever it is, like you will get all of this detail. Here, the symbol says that, okay, this table has been referred in one of my ETL pipeline, right? This says that, okay, so this table has been used in these two views or materialized view, right? These are the unknown. It means that like some of the UI application is referring this particular tables, right? So when we click here, we're gonna get the dependencies. So this is about the lineage, what we were talking about. Here we can get the overview, means the history, when this table was created, who created it, who all are having access on top of these tables, right? Every details would be covered under the overview. We can also see some of the sample data. If I would like to see, okay, how many columns this table has, right? I can see some of the sample data there. Then we can have like a permissions, right? I can check, okay, who all are having permission to see these tables. Even we can check the history. Okay, how many, okay, let's say, we might have experienced this, right? All of a sudden, one fine morning, when you log into your database, and when you do a query on a table, you see that, oh, somebody has wiped out the table, And then we don't know. People say, no, I didn't do anything. I didn't do anything. I'm talking about like 15, 20 years back, right? This used to happen. So here now we have that history within the same table. If you click, you will understand like who log in and who touched this table. If it is a job, you did it. It happens more now. More now? AI, the entire database. That's true. Yeah. So it's like, I think advanced technology will give you more challenge, and it's like, kind of a cyclic process, right? More security, more threats, and more threats, more security. Yeah. So yeah, so likewise, like we'll not go into detail, but just what I wanted to say is like this is the Unity catalog, the features, right? So here, if you see, this is just like a one EDP, one basically enterprise data platform common dimension, right? Which I used here, but like I can have a multiple schema. I just need to do drag and drop and just create those tables here to use in my schema. So one thing, let's say if I'm creating a view here, right? I cannot directly put some different catalog and schema to use it here. I literally have to create a link, and I can only create this link provided I have access to this EDP catalog, right? And when we create it, it gives me like, the EDP. It means that I understand that, okay, this is coming from the EDP catalog. So even I don't need to click and check that. So these are the features given by the Unity catalog. I'll go to the next slide just to summarize, right? Till now what we have discussed. So first thing is ingestion, the storage, and the governance, right? So ingestion, like basically the resources on demand, we already talked. Just to recap quickly, it gives us like a delta live tables, real-time streaming, and the batch processing that has been supported by Databricks. Storage, as I said, like, we can use our own cloud. It would support Delta Lake and open format, basically, right? It can be like kind of a Delta format or a Parquet format. It is very cost effective because it's like, like you pay as you use, right? And then the governance, that's what we discussed just now, the security, lineage, and discovery. And then let's say once I have a data sitting in my Unity catalog, right? I have prepared views, I have prepared tables, I have some soft links, and everything is ready. Then the next part comes, which is like a processing. Processing for what? Processing to train my model, right? Now I'm just switching a bit on AI side, basically, right? So I just use like, so here, we're gonna present the use case, but again, that use case is on top of Unity Catalog, right? So we are using Unity Catalog as my source. So as I said, like in the Databricks as my like processing pipeline tool, ETL. So we use Photon Engine. It is like a very faster, and we do like a vectorizing, right? So VectorDB is our source to train our model. Then we can feed this data into our AI ML tool, and then the last part is consumption. So you just prompt on top of it, and we will get answer real quick. So this is what so far we have discussed. Again, just to highlight, right? So we have this open format. So we are completely like kind of, vendor independent. And these are the highlight, basically real time and the batch job. It supports both of them, the combination. Governed access, security by the design, right? So in the Unity catalog, if you have access to a given object and the row and the column as they are proposing in this year, we can access, and then the open standards. So now moving to the next slide where we're gonna talk more about processing and AI and the consumption part. Yes, so part two here. I think some of some of us already attended like this session, like we had it one with Prashant, right, at AIS. So we're gonna repeat it, but here we are not going to put a demo. I just taken a screenshot, and we'll just discuss those screenshots basically, right? So now the AI virtual assistant, right? This is on top of Databricks and Unity Catalog. So today we're gonna see like what problem we had, how did we solve the problem. We will also go through like high level architecture, and then we'll also see like some of the slides, basically how, let's say, if user is using that AI tool, what he's going to put and how fast and what kind of information he's going to get, right? Then the business impact and some of the roadmap of what we have down the line. Yes. So service agent virtual assistant, right? So as I said, like this is on top of our Databricks and Unity Catalog, right? Uh, so like I work for like healthcare and life science industry, right? So for any healthcare and life science industry organization, every minute of like instrument downtime matters, right? Because it sometimes directly or indirectly impacts patient health. So in this case, we need to make sure that the instruments or any equipment, right, it is like up and running nearly 24/7. So in case my customer reaches out to me by raising a ticket saying that, hey, this instrument is not running as expected, it has to be resolved as soon as possible, right? Our field engineer basically, right? So the company where we work, so definitely like every company, when they build and sell some of the equipment and instrument, they would be having field service engineers. So our field service engineers, they resolve thousands of customer tickets in a year, right? And to resolve one ticket, they need to go through like, series of historical data in the tickets for that particular instrument, because not necessarily every field service engineer might have received those kind of issues in past, right? So for example, let's say, uh, okay, I am a auto mechanic, right? Repairing a car. So maybe I might be very good at repairing, like, let's say, for example, a Ford car. But now the ticket what I have received through my company, and I have been assigned to a ticket where the car might be, let's say, a German car, maybe a Mercedes, right? So the mechanism would be different, right? So the person would take some time. So we need to solve this problem because, sometimes what happens, even my field service engineer, he travels on a site, but may not be able to solve the problem. So this is like one of the challenge, right? In a year, it has to go through like, multiple service history, part replacement, and the troubleshooting notes, right? And that too, all this information has been put across multiple systems. So what we were thinking is like, to integrate all these systems using the Databricks and Unity Catalog, and then build some AI agent which can help my service engineer to get the quicker solution and resolve the problem, right? So based on the ticket history, right, basically my service engineer is going to solve the problem. Just to give you one hypothetical scenario, right? Let's say one fine day, my service engineer who is in like, let's say sitting in Europe, one of the city in Europe, right? He's getting a ticket. It says that the pressure fluctuation in an instrument, which has been used in one of the hospital, maybe 300, 400 mile away somewhere in the countryside, right? So by looking at the description, the person feels that looks like we need to change some of the filters which are used in the instrument. And if we replace those instrument, the instrument should work fine. So let's say when we feel that our car is not giving enough pickup, right? What we do generally. So we try to go to mechanic, we try to change oil and replace the filter, and then we see the smoothness in a car, right? I mean, we can immediately see the difference. If we are going after 6 months, we'll definitely see a difference. After changing a filter, it will work. So by keeping this in mind, my field service engineer, he might have taken a flight or, like drove a car to 400 miles. He went there and he realized another field service engineer already visited the site a week back. He replaced the filter, still problem persists, and that's why customer has raised this another ticket. So back to square. Now we realize that the problem is different and deeper. And he did not carry any parts or tool this time, right? So he has to come back. And remember, this tool was under warranty. So cost is going to go back to the company who is selling this instrument. That is one thing. Cost is one thing. Second thing is customer dissatisfaction. Because after a week, still company is not able to solve the problem. And on top of that, if he's a hospital, it may impact or it might be already impacting a patient health because someone is waiting to be treated because of this instrument, right? So this is kind of, like a one real-time problem what we had. And just to solve this problem, what we decided is like, we need to have a tool on top of Databricks and Unity Catalog to solve this kind of problems, right? So, I mean, I just put like some of the promises, like basically what we were trying to do. The first thing, we wanted to have a tool which can support the natural language, because my field service engineer might not understand all technical stuff, right, of AI stuff. If he puts pressure fluctuation, it should get the solution without putting any other details, right? The second thing, right now my engineer might be putting like 2 to 3 hours to gather the detail. Instead of that, if I put like a small query, it should give me answer within 2 to 3 minutes. So basically we are trying to transform here from 2 to 3 hours to 2 to 3 minute solution. And many times, even over the call, we can solve the problem, right? If you know that, okay, I need to restart the machine, I don't need to even go there. So while customer is over the call, like, he's saying, okay, pressure fluctuation, I can just, put a prompt. If I get the answer saying like, okay, restart the system, if I ask my customer, it's going to save a travel cost. So who are my target users, right? So it's basically FCE, field service engineers, some support technician, and my customers. Because customer are for like a DIY project, right? So if they can do self-service at their end, even they don't need to wait for any field service engineer on site, right? What are the pain points with our existing ETL? If we talk about like informatic and all those things, right? The information is in silos, it's like a time wasting, right? And all those things. So basically, okay. And then one more thing here, right? Without using this tool, what happens is like a knowledge loss. Let's say a field service engineer is working with a company for 30 years. Now, this is time to get retired. So that guy is carrying knowledge of 30 years. And when you onboard a new person, it would take time, right? So that knowledge loss is going to go away if we build something on top of Unity Catalog using AI. This is like very high level architecture diagram. Again, so whatever you see here is based on the Databricks and Unity Catalog. Even my ETL pipeline has been written to train my model in a Databricks, right? So it could be like, any of my database, different database. I'm just integrating all this detail into my EDP. EDP stands for Enterprise Data Platform. So the data would be stored here in form of like a Delta table or maybe a Parquet. It would be in S3, as I said, right? This is our actual uh, project diagram. So we are using AWS, right? And then once I have this data here, what I can do, I can pull all of this object into my Unity catalog. So as we saw in the last slide, right, I can take it in under the catalog schema and the table. So whatever table I would need, I would put everything under my Unity catalog schema. So now I'll be having all the details available here. So here, I mean, if I talk about the particular given use case, right, what we were talking was like ticket history. We have all the ticketing details, right? So I can take whatever tables I need. I would need like, ticket history table, customer contact table, then maybe cost summary tables, right? Whatever tables basically. So all of this information would be like, kind of a normalized, right? So it would be in a different table, which you can join using some of the keys. So all of these tables, I would bring them in Unity Catalog. Once I have all of these tables, what I'll do, out of all of these tables, I might not be required all of the fields. What I would need, I need the ticket history. I would need all the ticket descriptions, customer comment, my field service engineer comment. Let's say the field service engineer says that, okay, I did this step, this step, this step, I changed this many parts. And this is the time what it took, right? And then the costing part. So let's say I may bring like a 10 different tables, but out of all these 10 different tables, if each table is having 100 fields, I might need just 10 fields. So I don't need to process all of this. What I'll do, I'll just, join all of these tables. I'll create a materialized view, right? Which we saw in the previous slide, and then only bring the fields which I would need. So now I would be having, let's say, one or two views ready with all the raw ticket history informations. I'm going little technical. I'm sorry for that, but just, just to, connect the dots here, right? And then the first thing first, since the company is selling instrument all over the world, it might not be necessary that like, it might be possible that like, some of the information are in non-English language. So first thing, by using the OpenAI libraries, we need to translate them into English. Right? So the moment you feed the ticket description, it automatically understands what language it is written in, and then it can translate it into English. So that is like a first step. I'm just giving you some background here, right? So that is first thing. Now the second point, right? So now I might be having like a ticket description. I might have like my field service engineer comment. That I might be having a feedback from the customer. I might be having a different text field. What I need to do, I need to take all of these fields and I need to summarize it in just like a one plain field, right? So that is like a second field. Again, to summarize, we are using Unity Catalog and Databricks and using a OpenAI library. So now I have a summarized data. The next part and the interesting part is like a vectorizing, right? I need to vectorize and embed this data so that like when I use my AI, it will be quicker and I can get it like, with my basically human natural language, right? So this vector index, right? So Databricks is having a capability. It supports like, vector search index. It has like inbuilt feature. So if we use that vector search index, what it will do, it will consume whatever final materialized view I have, and then it will just, publish the vector database, right? So if you see this arrow, it says that this is like just like a training a model. So now I know that like all my ticket history, let's say I have like roughly around 400,000 tickets from the history, right? All of these tickets are present right now in my vector database. Now the second step is just to integrate this with like, one of the AI based front end tool, right? Front end screen. So I just need to have like a one screen. My user will just, put a prompt there, and that prompt will also get like, vectorized because I need to do search in my vector database, right? So that is kind of, like I would say, let's just assume that it's like in a binary format, right? Somewhere, let's say if I put like, okay, pressure fluctuation. So it's somewhere sitting in my vector database in 3D model, you just assume there is a dot saying that pressure fluctuation. And now when my customer comes, or maybe field service engineer putting like, okay, pressure change, right? So the pressure change will again get vectorized. It will just, try to search a similar pattern in that vector DB in the 3D model, right? And then whatever information it finds nearby, it will just get all of this detail and will give it to the front end screen. So this is like high level architecture diagram. I'll go to the next, like it will be more interesting when we see the screen. This might be little complicated or maybe like you're confusing. Yeah, go ahead. Maybe we can take it later if you want, right? Yeah, maybe. So this is slide number 10. We will come back here. Yeah. So let's say this is like kind of my sample UI, right? Which is, as just asking me, okay, what I need to do. I mean, I can just put my details here, right? So there are two things. I just explain you briefly, right? I'm just saying here the knowledge base and the service history. What does that mean? So as I said, like, the company is selling instrument, right? So along with the instrument, we always give a manual, a PDF file. So that PDF file might be like, maybe 50 page, 100 page, 200 page, right? For each instrument, there will be a PDF. So that is called the knowledge base, right? Because let's say I have a total 140,000 different instrument or maybe a parts, right? So for each part, I'll be having a PDF file. So we scan all this PDF file using the reg and all those. We do chunking, we train our model and we store it. Again through the Databricks, right? So that is kind of a knowledge base. Second thing is service history. What it will do, it will go to a table and get all my ticket history. So there are two parts. One is like a PDF file. Second thing is my data. And the third thing, we are giving a choice to my field service engineer. Do you want to go to PDF? Do you want to go to database, or you want to try both? So if the person, if my field service engineer is selecting both, right, then I'll get the other fields. What are the other fields? Basically, just to narrow down the possibilities of my search, right? I don't want like, very wide range of answer. I can particularly say that, okay, I have a Ford car, this model, and this is the problem. So that it just, try to find out something for the Ford. It doesn't go to like all other car brands, right? Just giving an example. So I'm just putting my product line, product family. So these are like optional field. If I put it, it will just narrow down the search. And when I put all of this detail here, it says enter your problem statement, right? So I'm just putting here the pressure fluctuation. The moment you put that detail, it will start giving me the detail the next minute, right? So see, here is my problem statement. It says the pressure fluctuation. And then this is a response from ask our docs, which means that it is coming from the PDF files, right? So all of this detail related to the pressure fluctuation with the selected product family and product line, right? It found this detail. And here it gives the citation from where it is bringing these details. So my field service engineer can search that. So this is from my knowledge base. If we go to the next slide, this is from my ticket history, right? So there will be a two slides basically, or two screens we are going to get, right? So see, if you see here, it might find like more than 100 tickets. What it will do, it will first give me only 10 tickets. Okay, how do I decide the order of 10 tickets? Depends like, which particular ticket and the field service engineer has taken a less time and the less parts. Because that's what as a company I'm interested, right? I don't want to spend too much money to repair my instrument. So this is what it decides. Basically, this is ordered. This is basically sorted by the costing and all those things, right? So I'll get like 10 tickets. If you click on that button, like more tickets, it will give you like more tickets. So now I have all these tickets. By looking at this, like some of the failed checks and some of other details, I feel that, okay, these two tickets are more promising to me. I would like to get more details. If I tick these two, like, I start getting the details here. And that too in a detail. If you see the list of tests performed, then the parts used, and then the labor cost. Right? So all of these details we're gonna get it here. So that is one thing. So I can just, select this. I can get all the tickets here. Second thing, if I am interested to go inside it, like what exactly was the problem, and I need to have some more details, right? Actual details, because these all details are like, kind of a AI summarized detail, right? As I said, like I might be having a multiple fields, but I just summarize them using the open AI. But if I would like to see the actual details, I can click on the tickets. It can open the web page where actually this ticket was raised, just to get all the details, just to understand who was my customer, when this issue was occurred, right? And all of these things. This is one way of doing. If you would like to select one ticket and get the more details. Let's say if I have a two ticket and I would like to understand, let's say I have a two tickets, I have all the details for it, and I would like to ask some follow-up questions, right? I can also do so. Right? So now I'm selecting these two tickets. I can have these details, and I see I'm putting a follow-up question. Give me summary of the steps for selected tickets. I selected two tickets. For both the tickets, it will take all of this as information input, and it will give me the summary here, right? So likewise, now my service engineer who used to refer opening the PDF file for the instrument, looking for some of the similar ticket history in my database, he doesn't need to go anywhere. It's just one-stop solution. He just put a prompt like we do it in ChatGPT, right? Now whatever you ask, it will give some details. But that might be having hallucination. Here, we have made sure that it does not do any hallucination. If we do not find the relevant ticket, it will just say that the rocket did not find. Uh, if we talk about some of the business values, right? Ticket resolution time has been improved by 70%. Of course, this is obvious thing. If we reduce our time, from hours to minutes, it's going to reduce the time. These are some of the snippets from our dashboard where we are tracking it, right? So, I mean, this product we just implemented, in 2025, it's been just 1 year, I would say, roughly 14, 15 months. So if you see the graphs are going down. So basically the average labor cost, right? If you see the part recommendation accuracy, right? It is slowly the accuracy is getting increased, and we don't need to make a repeated visit. So even there we can see very high improvement. The knowledge transfer is stays with us. Basically we are preserving knowledge 100% because it's not going anywhere. It's going to stay with my tool. And then the training course, right? So when I have a new field service engineer, I just need to teach him some of the alphabets. I mean, alphabets in the sense some of equipment details, how to fix this and that, right? And, and then if we are hiring a field service engineer, he would be having that knowledge, but we don't need to train him with literally, okay, this is my equipment, this is how we fix it. The guy can, search and get the details. So far in a year, this is our assumption, more than 50 international customers, right? They have started using this to solve problem. They are doing the self-service DIY. More than 1,500 field service engineers are using it. And then daily queries, right? We keep an eye, as I said, in Unity Catalog, we can keep an eye, right? We are seeing that more than 5,000 questions have been asked to this tool through this, right? And then this is our score. So this 82, because as I said, if some of the tickets or some of the ticket history is not available right now, it is not giving the solution, right? So that is kind of a limitation we have, because if we don't have history, it won't tell us anything, because instead of doing hallucination, it will just say that okay, relevant information did not find. And that these are some of the experience what we have from different person, like a service manager, field service engineer, hospital, and the customers. uh, and then the roadmap. So right now, if you see, we are in we have completed phase 1, right? The reactive support, where I'm getting a ticket, my service engineer will search for the detail and we will solve the problem. The second phase where we are working right now, it's in progress, the predictive maintenance. What does it mean? So let's say my field service engineer, right, is coming to repair one of the medical refrigerator or laboratory refrigerator. And he is there because there was a complaint that the cooling is not enough. So let's say they are setting up maybe 30 degree, right? But whatever they experience, it doesn't look like a 30 degree. So there is some temperature variation, or display might not be accurate. So the field service engineer is going there, and we need to fix it for free because the refrigerator is under warranty for 5 years, and it's just 3 years now. So when my field service engineer is searching and just getting the step, at the same time he will also get a pop-up. What that pop-up says, it says that okay, this given instrument is having a warranty for 5 years, so 2 more years to go. And for a similar refrigerator for other customer, we have seen that after 4 years a lamp is going to go, the lamp is going to die. The cost of the lamp replacement is like a $10, and if you come back, it's going to cost you like $500. So upfront you just replace this lamp. So based on the this equipment behavior for some different site, it can suggest to the field service engineer whether to replace or not to replace. Okay, other thing. So now the field service engineer is there after 3 years. It would also propose that some of the parts, maybe let's say the compressor of the refrigerator, right, is going to die after 6 years, maybe 1 year after warranty. Then my field service engineer will do upselling to a customer saying that, hey, you need to extend your warranty because after 5 years, we have seen that this many compressors might fail. Otherwise, you need to pay from your pocket. So that is kind of, like a predictive maintenance, what we are working right now based on the history, right? And then the third one is like enterprise expansion, where we are also going to support our marketing team, because our marketing team does not know I mean, they know, but they need to do like a lot of research. Okay, which particular customer is using which instrument? Because, like every 5 or 10 years, we would be having like some revised model, right? As we know our iPhone, we know that every year we're going to have a new model. So if iPhone would like to increase their business, what they need to know? They need to know that, okay, who all are using like iPhone 12 right now? And then they need to reach out and say that, hey, you just pay like a $30 per month, and these are the new feature you are going to get. Right. But for that, they need to understand like who all are my customers. Okay. The second thing they need to know, okay, all iPhone 12 users, how many of them came to our service center and said that, hey, my screen is not working. Looks like my phone is slow, right? So we need to go through all those ticket history and see like, how many customers have spent already behind the maintenance. Then we're going to go back and say that, hey, your refrigerator is really old. It's been like 15 years. You have spent like, 10,000 for the maintenance. We see that it is not under warranty. And now we have a similar, but the latest model, right? So this is one thing. Second thing, we also compare with co-vendors, right? Saying that, okay, this one is having these features, we are having these features. So basically it prepares a battle card for my marketing team. What my marketing needs to do, if my marketing team sitting, let's say in the North America, they just need to select the North America region. It will give the list. And then from that list, we can understand, okay, let's say solution state is using our 42 instruments, right? It's like having a highest instruments. So that's kind of a low hanging fruit. We know that out of 42, there would be an opportunity at least with one or two, right? So we are getting those kind of details. So that's what our expansion plan is. I think we can move to the next slide. We have roughly 12 minutes and we can go through like our some of the questions.
Okay, so if I'm understanding what you were talking about in this case, you're essentially using AI is involved in various ways in that, but you're pulling back and relying on PDFs, right? And the knowledge base from other experiences and so on, and the PDFs that the manufacturer makes. Is there any idea in the future to look towards actually using the AI capabilities to actually help diagnose a problem? Because that's frequently where a lot of the issues come, is diagnosing a problem. It's not, you say, okay, I have a problem, you send the technician there, but you may have a lower level technician who may be able to handle it, you may have a higher one, and if you can diagnose what it is using the data you have, then you say, we only need a lower level technician to go take care of that. And you can also look for patterns and all kinds of other things within that. And I didn't hear that part of it. I'm not sure if I missed it, but is there some way to help you do diagnosis with that?
Oh, that's a very good point, actually. Like this was like one of the point we had during the discussion, right? So main thing to propose the diagnosis, what we need to do, we need to keep like, the accurate real-time data from that equipment, how it is behaving basically, right? So let's say if I have a ticket saying that, okay, my refrigerator is not working fine today, it means that I need to know basically how it has been doing in last 1 year basically, right? So we need to have basically, so for that, to be honest, right now we do not have any plan as of now, because like every equipment has to have some real-time data streaming to our system. Then we can understand, for example, let's say Tesla can do it, right? But let's say if I have let's say, for example, another brand car, let's say Honda, right? So Honda might not be having that feature because I don't have a direct connectivity with my company. So Tesla can tell you, hey, I think when you were putting in autopilot, you were sleeping. Right. So there we can do that diagnosis and we can fix it, because it can give me real-time data. But for now, I think you didn't miss it basically. So we didn't have anything in this presentation. Yeah.
The plan is to get.
Yeah, correct.
I get it.
Yeah, thank you. Huh?
It's kind of piggybacking on that question, but maybe more rudimentary. Could you go back to your slide 10 for a second?
Oh, yeah, sure. You said 10.
It's really a question about where do those sort of PDF manuals come into play here? Is that sort of just loaded up front and then you're creating, your vector database based off that? Like where you talked about the tickets being.
No, I understand. Yeah. So basically here, I have shown only one pipeline, which is like, getting data from the ticket history and from the service database, right? So here, the PDF is basically altogether a different pipeline. So like, we have two different pipeline, right? So one pipeline, which is like, all of these PDFs are sitting in SharePoint in our company, right? So what we do, we have a pipeline which reads each PDF file. We have done the chunking and we are just, training our model, right? Okay. So now the question is, tomorrow, let's say if I'm revising a PDF, what will happen? So next day, when my Databricks job runs, it just goes and find, okay, which is the modified document since yesterday, right? And we will only pull those PDFs just to retrain my model. So yeah, that's a good catch actually. So I didn't put that flow here.
And a follow-up question would be, how long did it take for this to get set up when your initial deployment, when it first had to train the model with this humongous history of tickets and all these PDFs, so that you could then start actually using it in the field.
Yeah. So you're not talking about the pipeline side. You're talking about the processing,
Think
right?
about the process.
Yeah, yeah.
Right.
So we took 43 hours, to be very honest. Yeah, to go through like 140,000 PDF files and roughly around 400,000 of ticket history. But the main time it takes like, in like a translation, right? Or translation. And the second thing, since we are using OpenAI, it has some like, token limitation. Right. Yeah. So it cannot like, just, keep running, right? So we have some token limitations. So honestly speaking, even if I am not missing, even we had to kill our job and restart it. But when we restart, basically we had that pointer. We know that okay, till this point we have already processed our day. This is like a one time pain for
Right.
sure. Yeah.
And now it keeps up.
Yeah,
So
yeah.
it's something
So
I think
now
you-
basically now, it's incremental, right? So I don't need to worry. So wherever I see a ticket change, maybe like, because, every table would be having like a last modified field, right? Audit field basically. So I'm just, putting that filter. Wherever I see a change, I'll only get those things and retrain my model. Otherwise, I'm all good. But yeah, first time it takes time. Yeah. Yeah.
On the slide as well. Can you talk more about the training of the model part? So there is embedding model,
Mhm.
right? Is this semantic model or is this, like, what does this refer to? And also like piggybacking on this question about PDFs, are the PDF segmenting and processing stored in the vector search or can you just share a bit more?
Yeah, definitely. Yeah. So, okay, I'll take the last question first, right? Yeah, the PDF and all those things, yeah, those are getting also stored in the vector search, but that's basically a different vector table we have, right? So we have kept two different tables. So basically it depends what option you are selecting. If you say just knowledge base, then I'm going to go to that table, right? So remember we had the two options on a screen. Yeah, tickets, right? Yeah. 1 second.
They all are indexed in different vectors.
Yes, yeah, right. So basically, if you select the knowledge base, then I'll go to this table. If I select the ticket history, then I'll go to the, like a vector table where I am storing the ticket history. When I say both, then I'll just, query two different engines and then two different tables, and then we'll just club the details.
But twice. Like, why would
This is for the field service engineer, right? Because let's say, for example, because I being a field service engineer, right? Probably I would like to understand more about like, okay, pressure fluctuation for a refrigerator. I would like to see, okay, I think, like this is a standard problem and it must be there in my manual. Then I don't need to go to the ticket history. I don't need to worry what exactly you have done as a field service engineer to solve this problem. If the solution is there in my PDF, I don't need to worry. Some of them say, I don't care about the PDF. Just, let me find out 5 other service engineer what they have done, right? And then I'll solve my problem. Yeah.
and can you talk about the training?
Yes. Yeah, I'll go there. Okay. So, so let's assume that like, my data is there in my Unity catalog now, right? So I'm fine now. The first thing is like, as I said, like I need to translate my data. So now everything is in English, for an example. So let's assume that I have 5 different tables and all of my data is in English now. Because, that is the first requirement. I need to convert it because, I need to train my model and I wanted to train my model in English just to be effective, right? And then the second thing is like a summarization, right? So now what we do, like by using the OpenAI, right? We will just do a summarization. So now what I'll be having, I'll be just having a ticket history, ticket summary, and some of the other like numeric fields, like, okay, how many parts it has taken, the cost, and all those things, right? So once I have all of this detail, Databricks is having like an inbuilt library that is called like vector search index. Right? So by using that vector search index, what it does, you just need to mention this. Even this vector table, I think I forgot to take a screenshot, but I could have taken it. Right? This vector, by using that vector search index, what it will do, Databricks will create one vector database table within the Unity catalog. Right? So if you do a query on that table, you will just see like, some binary and decimal and all those points. It has no numeric or like, plain English data, right? So that is kind of my vector table. Now what happens? When I do a query, again, that data will be vectorized. So let's say when you say a pressure fluctuation, right, it will be again vectorized. And then it will try to find out that particular stuff, right, in my vector database. So if you see here, see the SQL warehouse endpoint and then the vector search endpoint, right? The first thing first, what it will do, whenever I do a query, it will go here, it will translate it by using the OpenAI library. I'll just search here, right? I'll get all the similar tickets, but still these tickets are in basically the vector form, right? And then the vector form, I'll just take it back and then we'll search here in the SQL warehouse, right? Just to find out the actual data, right? So basically I'm storing the actual data and then the vector database. So vector database will be sitting in my Unity catalog and we are preparing this vector database. So when I say vector database, you can just consider like, training a model basically, right? So that's what it is. And that we are doing using vector search index, which is a inbuilt capability of Databricks. Yeah. Uh-huh.
The question maybe is outside of this scope. We have a huge database, like every morning, every night we can process all the data. But sometimes the customer, they see, put the data over there is not like no out of the definition, like a length or whatever, the embedded character or whatever. They will break down the process. How do you think how do we can use like an AI to resolve that issue? Otherwise we've spent lots of time to find, oh, this line, has some embedded character, or this is over the limit, it defines a 50, then it will be 53.
I think like, this is like a very standard use case, to be very honest, right? So recently, even in our projects, and many of us, I'm pretty sure like might be using it, right? We started having like our own AI agent, right? You just, train your agent saying that, okay, if you see these are the characters, then you just, say that, okay, this is invalid, and just, give me that particular record, right? So what we need to do, like, we need to have our own AI agent basically, which we can build. So if you, in your company, right, if you are using, like, for example, let's say where I work, we are having like OpenAI, right? We have a tie-up with OpenAI, right? So we started writing our own AI agent, right? Many of the things, now we are not doing it like, so for an example, now I think even in one of the other sessions, right, now we can say that, hey, can you go to my Jira board and give me my top 5 high priority tickets, right? So, basically, okay, just to one-liner answer to your question, we need to just write one simple plain AI agent. That's it. It's pretty simple, to be honest.
So, given that you're using AI agents to be directly accessing data, what are the evaluation policies that you're doing to evaluate how accurate the AI agent is using? Are you using another agent to be able to judge the accuracy of the agent? With the LLM as a judge model, or are you just doing it through manual? So one of the things I understood is that you're making sure that its knowledge base is only the tickets. But how are you evaluating the efficiency of the agent that?
Yeah, makes sense. Yeah. So, okay. So first thing, like, we had a pilot project, right? The second thing for us, we are not fetching anything from the web, right? It is all like either knowledge base or ticket services, right? So, to be very honest, we have 100% accuracy because, we are giving a limited source. We are saying, okay, this is a room, you just pick one out of it, right? So it's not going to say that, okay, someone from the, other land, right? So that's why, we did that experiment, right? So initially for 3 months, we did a pilot project with only limited and selected field service engineers. We heard the feedback, and then we just implemented. So we have a CIS, the security team, and all those things, right? Just to make sure that we are just, staying on a lane. But yes, since my source is limited, I don't need to worry. The moment I involve the web here, it can give me anything basically, right? Yeah. So that is not the scope here basically. So we are good.
But you be running evaluations for measuring accuracy, right?
Sorry.
You must be running evaluations.
Yes. Yeah. So, there is a dashboard, right? Remember, I saw a couple of those screens here, right? Yeah, this one, right? So here, if you see, so what we do when my field service engineer is using my AI tool, right? What we do, like, after doing that, we're gonna just take a short survey, basically. Okay, so whatever steps given by the AI, have you used the same one or there was any change? Okay, how much percentage you use and all those, just to get the feedback, right? And then every 3 months, like, we are having a kind of a roundtable conference just to see that, okay, what are our feedbacks? In case if we see somewhere the field service engineer is saying that, okay, 30% only I got the right information, 70% was kind of, like off the track, then we just, try to revisit and see. Because I would say still we are in the process to train the model. It's kind of a feedback loop, right? But the feedback loop is manual, to be honest. So right now we are just seeing it. We said, okay, this is the ticket. Okay, what was the case? Why did we see this? Okay, this might be the reason, right? And then we go back to data and see that, okay, so we need to corner this kind of scenarios, and then we are doing it. We are fixing those scenarios in our Databricks pipeline. Yeah. So we are at 7:30. If you have any question, yeah.
So you are measuring accuracy based on the interview you are getting from the service engineers. There's nothing in place within the system to measure accuracy of the data.
So basically accuracy of the data, yeah, true. So basically this system is to give output, right? So system itself, let's say if I am giving the output, I might not be the right person to judge the accuracy, right? So it has to be like a third party. So it's kind of, I would say in the modern AI world, we call like human in loop, right? So this is something like human in loop, right? So when we get the output, right, what we need to do, like we need to have a human in loop. And again, this is kind of a healthcare and life science. So it's kind of like, I would say, and then again, the finance, right? All of these are kind of a regulatory industry where it is recommended, highly recommended to have like human in loop. It has not, it shouldn't be like 100% automated system. So again, this is for the equipment, so not that sensitive, but like, yeah, definitely. So here we have human in loop, and that kind of accuracy acknowledgement we are getting manually as of now.
When did this go on?
Last year, January. So it's been like 14 months now.
How many field service agents have retired? So you've done this?
Not to be honest. And, so for that, maybe like I need to go to employee table and see how many of them are a good one. Yeah. And so right now we are talking, tomorrow we are not sure, like, these guys will say, like, okay, we have something for you as well, and even we don't need you, right? So yeah, AI, yeah, it's like, kind of a two-edged sword. Yeah. Cool.
What's happening is that they send a newbie who doesn't know how to fix the problem.
Mhm.
So then they have to call the big guy, and the big guy comes and he's not even typing anything in the system,
Yeah.
It's just go straight and see what's the problem.
Yep.
That's
Yeah.
why- And the next question I was about to ask you is, who's generating the report for the tickets?
Who generating the report for the day?
report? That's a ticket, like, you must enter information on what happened. Who's entering that information?
Of course, the field service engineer, right? So let's say, for example, you are a customer, you will just go to our platform called Service Central. That is a platform name. You will just go there and raise your ticket, right? What will happen internally? It will be assigned to one of the closest field service engineer. Let's say I, being a field service engineer, I'll be assigned to it. I'll just go through the ticket. I'll just use this tool based on your description and all those things. I'll get the answer. And once I solve it, I'll just put the details, right? Okay, these are the part I used. These are the steps I followed and all those things. So there's like, standard, the template what we have.
You gotta trust the technician grammar, right?
Yes.